Now let's look at how we can pop items from our stack. So as we talked about this in the beginning of the lecture, we have two major operations on a stack. We have push and we have pop. Push would add element to the stack and pop would remove elements from the stack. And also we said that the stack is growing from high address to lower address. And that means that whenever you're adding a new element to your stack pointer or the address of the element on the top of the stack is actually decreasing because your stack is growing from high address to low address. Whenever you are popping element from your stack or removing element from your stack pointer is actually increasing. So the address of the stack pointer or the content of the stack pointer is increasing because it's basically the direction is opposite. So here we have the same scenario. We have a before situation, which is showing the register and the memory, and we have an after situation or state that it's showing the content on the registers and the content of our memory. So before running this code, on the stack pointer, we have this address. So even without looking at this memory, by just knowing this information that our stack pointer has this address, you should assume that there is something here in this address on the memory. So there is some item that basically is top of the stack. So that address contains some value that is part of your stack. It's basically the last element or the top of the stack. So, and you can see this address is here and we have the content actually written here. So another thing that you could assume just by looking at this is that any address less than this, so if we are going in this direction, we are looking at the small numbers, any address less than this, the content that are here are unknown to us. So that content are not part of our stack. Technically, they could basically hold some value. They could have some content in them, right? But from our point of view, it's kind of like garbage. It could be some data that is there from before, is not erased or anything like that, but we don't know. So it's something kind of like you can think of it as an unknown. And that's basically any address is smaller than this, so in this direction. Any address larger than that, it's gonna be the other items that are in our stack. So that means this item is actually something that are on the stack. That's the next item from this one. But this one, we don't know. So, and by the way, the reason that we don't know this one is that we never actually clear this memory. Like we're not gonna hard code or reset these values to 0. When we are popping from the stack, let's say I'm removing this item, I'm just gonna like all I have to do is just move the stack pointer here, and that's it basically. This value, this location, it probably is still gonna have the same content, but it's seen as basically an empty spot or some spot that we can overwrite the content. So that's actually how it's done. So not always when you delete something, even if you have like a flash drive, and not always when you delete a file from that flash drive, that content gonna be actually erased. There's a way to do that. That basically it's gonna write like all like zeros, let's say, on your whole flash drive. But that's not the case usually, and that's why it's very fast sometimes to delete. If you look, for example, if you're putting like a 1 GB file on a flash drive, it's gonna take maybe a minute or 2 minutes to do that. But if you are deleting the same file, it only takes basically like instant, right? It maybe takes 1 second, not even. And the reason is that because when you are deleting, you are basically just unlinking that file. So you are just marking that area as empty, but you are not actually resetting all the bits in that area to like 0. You are just marking it as empty. So this is the same idea. If I'm removing this item, I am not actually resetting these bits to 0. No, I'm just moving my stack pointer from this location to the higher address, like here. So as soon as my stack pointer is here, I can assume, or anyone else who's, let's say if I'm calling another function or another program is running at that point and take control, not knowing anything, they can assume that this address is basically garbage and they can use it. They can overwrite the data there. Okay, so let's look at the code now. We want to put pop one element from our stack. So this is the top of the stack as we established. So this address is pointing to here. So that means that's the top of the stack. And we want to pop that item from our stack. So the way it works, we want to basically save it to a register. So when we remove this from the stack, usually you are basically getting that element. And we want to write it in register 19. Technically, you don't have, if you don't want the value, you can just move the stack pointer. But in this case, we want that value. So, and we are choosing to write that value to register 19. So what we are doing, so stack pointer is here. We are moving the stack pointer to the next position. So basically we are adding 4 to that. And as we said, in the push we did -4. Here we are doing a 4. So we are adding 4 to that. And the stack pointer now is gonna come here. So it's pointing to the new top of the stack that gonna be there after removing this element. And then we are doing a -4 when we are doing a load word. So before that, load word we said is taking from memory to register. So that's why we are using this, because we are reading from the memory. The stack is always on the memory. We are reading from the memory, we are writing it to register. We are giving the register 19. That's our destination. That's gonna have the data. And this is the target address that we are reading from. So the stack pointer is moved now here to this location. So we are reading from offset of -4. So basically we're gonna read from this place, which was our top of the stack. And that's gonna copy this data to our register 19. So if you look at the after situation, we're gonna have register 19 filled with the data that was on top of our stack. So that's good. And then we have our stack pointer that is basically, now if you look at this one, C0, it's pointing to the next element on our stack. So now it's pointing at this location. So before it was here, now it's here. So it's moved to the next element. So that's good. And this one, we didn't actually like erase the data. We just move the stack pointer, and we can assume that that is gone basically. So here I showed you 2 ways to do that. So for pop also we can do it in 2 ways. So here first we move the stack pointer and we did a load word with the offset. Other way that we could do that is to first do a load word. So our stack pointer was already here, the location that we want. We could do a load word right then. So just to take this data here. And then after we have the data, we can move our stack pointer and update it to the new top of the stack. And both ways are valid. There could be a small performance issue depending on how many items you are doing. But both of them are valid. The most important things here is you want to get your data. That's number 1. And number 2 is that after you're popping, after you're done, your stack pointer should point to the new top of the stack. So it should point to a valid item that is basically the next on the stack. So here it's gonna point to this item.